my channel. So today I'm going to be solving word search. So yeah, let's just get into it. Given an n by n grid of characters board and a string word, return true if the word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. So keywords sequentially, keyword adjacent, keywords horizontally, keyword vertically. And then very important to pay attention to, same letter may not be used more than once. So let's just get into it. I'll talk about that later. So here in this first example, the word that we're passed is A, B, C, C, E, D, and this is our board. And we return true because we found A, B, C, C, E, D sequentially, and they're all adjacent horizontally or vertically. So we return true. The next example is C, and we have S, E, E here in our board, so we return true because these are sequential. This word has been sequentially found in our board, and these cells are adjacent horizontally or vertically. So that's why we return true. The last example, we return false because the word we're passed in is A, B, C, D, and we see A, B, C, we see A, B, C, C, D, but they're not sequentially placed adjacently next to each other, so we return false because we don't find that word. And then these are our constraints here. So the word dot length is less than or equal to 15. Board and word consists of only lowercase and uppercase English letters. So yeah, let's just get started. For this problem, so as soon as usually when I see like we're going to be looking like to adjacent cells horizontally or vertically to see if we can find something in a matrix, I usually just think of like there's two things I can do here. I can do a breadth first search or I can do a depth first search. This case I'm going to do a depth first search because we are going to find a cell like the first letter of our word, and from there we're going to do a depth first search. We're going to exhaust all possible paths. We can go right, we can go left, just horizontally, vertically, whatever, to find whether or not the remaining letters of our word exist in the board. So yeah, we'll perform a depth first search, and then some other things is basically when we start off, we need to traverse all n elements, or maybe not all n elements actually, but we'll need to traverse through our board, and we need to see if we find the first letter of our word, and if we do, that's when we begin like our depth first search operations. And yeah, we'll perform a depth first operation. So in this case, on cell A, and then from there, we're gonna try to find all the other characters that we need in that word. And then if we find all those characters, we'll return true. So now, in terms of the depth first function that we'll call, basically, we'll want to check, first. Actually, we'll get there. I'm just gonna start coding because if I explain, it doesn't do much good. Alright, so to start off, I'm going to check if board equals null, or board dot length equals 0, or or the word equals null, or word dot length equals 0, then I will just return false. Alright, and then now we can kind of get started. So the first thing we're going to do, we're going to traverse through our board, and we're going to look to find the first character of our word. So we'll say for int I equals 0, I is less than board dot length I plus plus, and then we'll have an inner for loop for int j equals 0, j is less than board dot length, board at I dot length, j plus plus, and then now we'll start. So we're going to want to return true or false in this method whether or not we found our word inside our board. So we'll do an if statement. We'll say if, first of all, if we find the first character of our word, so if board at, I keep thinking of the number of islands question, so I keep using grid. So if board at ij, if it So I'll just store it here to make it clear. So I'll say not int, char, first char equals word dot char at 0. And I'll say if board.I at j, if we find the first character in our word equals the first char, and so in our depth first search method, it's going to do the bulk of the logic to make sure to return to us whether or not it's found the remaining characters of the word. So right here just checks our first character in the board, and then from there we perform a depth first search on that first cell, but we also need to check, because we're returning true or false whether or not the word exists. We need to check that our depth first search function returns a truthy value to us. So we'll call our function dfs, and it's going to be passed in our board. It's going to be passed in 2 indices so it can know where it is and where to like traverse from and spread out from. And then it's going to be passed in our account variable. So the count will be incremented, and it will represent like the next letter of the word. So when count increments, like each call, like it will represent the next letter of the word. So hopefully that makes sense. So, and then it will also pass in the word that we're looking at. So we'll say, okay, DFS of the board, of I, of J, because this is the cell where we found our first character. So now let's perform depth first search on that cell to see if we can find the remaining characters. So board I, J will need a count. So in this case, count will start at 0 because we've only found that one character. And then the count actually we will also use to check. We'll also use the count to know when to break out of our like recursive like depth first search method, or just end the method. Because if our count is ever equal to the length of our word, we'll know, okay, we found all the letters. Our count equals the length of our word. Let's just return true. So we'll pass in a count. So in this case it starts at 0, and we'll also pass in the word itself. All right. So if this returns true, if both of these return a truthy value, then we need to return true, and we have completed that. And then if we get past this loop, we'll just return false, because that means the word was not found. All right. So now I'll write the depth first search function. So private, we're gonna return a boolean. Make it static. Private static boolean dfs. Pass in, like I said, we're gonna pass in our board. We're gonna pass in a board of characters. We're gonna pass in a specific, I guess, cell. So int I and int j. We're gonna pass in a count to indicate, like, first of all, if we found our word, and we're gonna use it to move to the next letters in the word. So int count and then a string word. Okay, so now first thing we want to do is check, okay, does count equal to the length of our word? So if count equals word dot length, then return true. All right. And then now we need to make sure to be checking boundaries. So we need to make sure like we don't go off the board, like to the left, to the right. We need to make sure of that. So we're gonna check if I is less than 0, or I is greater than or equal to our board.length, or j is less than 0, or j is greater than or equal to our board at 0.length, or, so we need one more check. I should probably zoom in. So we need one more check, and this check is gonna check if the cell we're at, if the cell we're at is not the character that we want, then let's just return false. So we're gonna say if board at I j does not equal the character that we want at the certain count that we're at. So we'll say word dot char at count, then return false. Okay, so we did our boundary checks. I think that looks good. Word dot char count. Yep. And then remember, count is going to be incremented, so that's why we check at count and not like at 0 or at 1, because we need to be moving along the word. Okay, so now that that's complete, we know, okay, there are remaining letters that we need to find. We still need to find remaining letters. we're still in the grid, we're still in the boundaries of the grid, and then yeah, we're still looking for our character. So this is when we need to think about this case here. The same letter may not be used more than once. So here, if we have an A, or like what any of these letters actually. So like for this example, there's two C's. So if we're at this cell, we want to make sure that like if we're looking for the next C, it doesn't say okay this cell is a match and use the same cell for both C's. So we need a way to mark this as empty so that if the other C doesn't reuse that cell, at least temporarily mark it as empty, because we can't just leave the board like that. We have to restore the board how we got it. So we'll say, we'll somehow need to store this letter C in a temporary variable. Not the letters, yeah, the letter C itself in a temporary variable, and then mark this spot as empty, and then continue doing our recursive calls and make sure to restore this C here at the end of that. So I'll say char temp equals board at ij. So this will store my letter C, and then I will mark the spot where the C is as empty, as an empty character, so that this C doesn't go and reuse this spot thinking, oh my god, I found a match, when in reality there was only one spot and there's two C's. So board at ij equals that, and then so that's covered for now. And then later on we're gonna have to restore it, so I'm just gonna write that now before I forget. So board at ij equals to temp. Alright, cool. So now between here, we're gonna need to. So now is basically when we start our depth first search, like recursive calls that will dig deep and traverse either four paths. So you have four potential paths to find the remaining word. So it can traverse, like it can go downward, like I said, horizontally or vertically neighboring. So we can go to the left, we can go to the right, we can go down, we can go up, but we just need to find the remaining of our word. So our depth first our our depth first search needs to be passed in four possible directions to go to. So we'll need a boolean to facilitate or to return whether or not we have found the remaining word. So we'll say boolean is found equals. So like I said, four different paths, four different options to traverse with our depth first search, and yeah, we have four different ways to check whether or not we found the remaining word. So boolean is found equals DFS. So I'm gonna write it under here. So equals actually, I'll just write it up here for now. So equals a DFS. We pass in our board. We pass in I. So first I'm gonna pass in I minus one. So I'm gonna say go above. Look up and J, and then our count. We're gonna increment count. Remember, and then we're gonna pass in the word. Okay, so this says, okay, look up and see if you can find the word. Go upwards. And then we're gonna say or we're gonna say go downwards and see if you can find our word. So pass in our board, pass in I plus one, pass in J, pass in count plus one, and pass in our word. And then we're gonna say or go to the left or go to the right and try to find our word for us. So let me just type this out quickly because it's kind of getting repetitive. So DFS board, I, J minus one, count plus one, and our word, or do a DFS of the board, I, J plus one, count plus one, and our word. Okay, so this will either return true or false depending on whether or not we were able to find the word in all four or one of those four directions. So board.ij equals temp, and then under here, so remember this just restores the places we marked as empty. So then under here, we're gonna return is found, and that will tell us whether or not we have found our our word. And I think that is everything. Let me just make sure I don't have like any crazy typos. So here we checked if board equals null, or board.length equals 0, or word equals null, or word.length equals 0, return false. And then we have nested for loop through the board.i. We got our first character. We check, okay, if we're at, if our cell is the first character of our word, and then a DFS from that cell returns true, then then yeah, we return true, and we have our word. Else we return false. Looks good. And then this is our depth first search method. So we have our board. We pass in int I, int j, int count, string word. We check if the word.length ever equals count, because then we know that we found all the letters, so we'll return true. And then we need to make sure to check our boundaries to make sure we're not exceeding the bounds of the board here. So I is less than 0, greater than or equal to board.length. J is less than 0, greater than or equal to board.0.length. Board.ij does not equal the word.try count, then just return false and break out of this loop, or this function or method. And then because we don't want to reuse the same cell for two different characters, we need to mark that cell as empty, so we store it in a temporary variable. And then we do a DFS, we increment our count, pass in up, down, left, and right, and then set that. Then we populate the cell that we marked as empty again, and then we return whether or not we found our word. And I'm gonna run this now, and accepted, and let's submit. All right, so that worked. I hope this made sense. Yeah, thank you for watching.